Hello and welcome to this short tutorial for the single span beam analysis spreadsheet, which is available from my website. So if you go ahead and click on this, it's going to download a zip folder, and you need to extract the zip file, and then within the zip file there will be a worked example with a PDF which showing you with the formulas for the single span beam analysis, and also an Excel spreadsheet. I'm going to focus on the Excel spreadsheet in this tutorial, so I'm just going to go to that here, which I already have open. So when the spreadsheet opens, you should get a little warning message, which is basically just a disclaimer about saying you should use your own engineering judgment and such when using the spreadsheet. And that's true for all the spreadsheets on my website. You should be using your own engineering judgment and making sure that the outputs and the inputs from the spreadsheet are correct and are making sense to you. Okay. But with that said, we're going to go into here, and basically along the bottom you've got a bunch of different design sheets. And the first one is the project info. So in here we can fill out the project information for the project in question. So I'm just going to add in some information here. So project name, I'm just going to give it the project. I'm just going to fill out some of this in here. Project number, let's call it 00. Actually, let's just do 1111. Client, let's just do me, which is Adam. Made by Adam. Checked by Adam. Date, we can set the date as today in here if we click that button. And then revision, let's just do revision 1. And if I clicked on this reset button, it would just clear all the data in here for you. Okay. So now that we've filled out the project information, we can go to the design sheet. And in the design sheet, we can either manually enter the project information up here, or we can just click on the autofill header, hit yes, and it will drag in that information from the previous sheet. So we've got all the information in here, and we can also add a description. So let's call this beam design 1. In there, and now we can go ahead and actually start adding information for the beam that we want to design here. So all of the headings here are labelled with numbers, and this is sort of the order you should go through and fill out this form. I should also mention that any cells that are light yellow are input cells, and any other cells will be formulas or headings. So only enter information into the light yellow cells. Okay. So in here we have the length of the beam. So let's put this in as 3 meters. And down here, the next one, we've got the support condition. So we can either have pinned, fixed or free. So I'm going to leave this as a simply supported beam, but you'll notice if I change these to say fixed and pinned, it will tell you what kind of beam it is. So that case would be a propped cantilever if it was fixed and pinned. I'm going to stick with the pinned, so this is a simply supported beam. The next heading here are the factors at ultimate limit state. So these are the load factors that are applied to the dead and live loads, or the permanent and variable loads as they're also known in Eurocode. So in here it's basically saying that we're timesing all of our dead loads up by 1.35 and all of our live loads up by 1.5 when we're looking at the moments and shear forces at ultimate limit state, which is the state that you design when you're looking at failure of the beam member. Okay, so that's what that's doing. Now we can go on to member properties. So the material properties are used for the deflection calculation, and these involve the modulus elasticity, E, which is in newtons per millimeter squared or megapascals, and this is basically a material property. So for steel it's normally 210,000, for concrete it will vary depending on the concrete grade that you pick, but this basically is how sort of flexible the material is within its elastic region. Down here we then have the beam type. And so we've got a bunch of libraries you can pick from. So we've got universal beams, universal columns, rectangular hollow sections, square hollow sections, circular hollow sections, parallel flange channels, so those are just channel sections, equal angles and unequal angles, and then we've also got custom. So all of these libraries in here, if you pick one of these, it will let you pick a beam section from the list. Okay, but you can also add a custom one, and I'll show you that in a minute with how you can add a custom beam. So you've got the section size that you can pick, and then you've got the axis of bending, so you can allow the beam to be bent around its major or minor axis as well in there. And you can see underneath it will populate the moment of inertia about the major and the minor axis, as well as the second moment of area used for analysis. So you can see here we've got our UB203 section that we've brought in, and we're bending it around the major axis. And so you can see that the moment of inertia used for the deflection calcs is picking the one for the major axis because we've selected that here. If I change it to the minor axis, it's going to pick the smaller value here. So it's going to pick 164 rather than the 2105 value there. So we're going to stick to major and we're going to continue. I'm going to quickly show you how to add your custom section in here. So if we go down here and go to database for the add a custom beam section, we can add a custom beam. So let's do custom 1. We can add in the mass of the beam per meter. So let's do 10.1 kilograms per meter, and then we can add in our custom second moment of area or moment of inertia in here. So let's add in 2000 for the major and let's do 500 for the minor, and then we can go back to design in here. And if I go back up to my beam type, I can select custom, and then I can select custom 1, and it will populate those values. And just bear in mind that the values that you put in the database, these are in centimeters to the power of 4 to make things a bit easier to add in here, so you don't end up with huge numbers. But in here, they're populated as millimeters to the power of 4. So just something to be aware of there when you're looking at, make sure you check your units when you're adding those in. But we're going to go back to our UB 203, 102, 23. So we're going to go back to that beam, and now we can look at our applied loading to the beam. So down here in section 4, you can include the self weight of the beam, or you can ignore it. And as you can see, if I ignore it, it will change this value here to 0, which is our UDL load, our uniformly distributed load. Or I can include the load. So there, we've got that included. That's the self weight at the 203. And then in the rest of this table, we can start adding our custom loads. So the first sort of area here, these are the uniformly distributed loads, and these will add a full length load over the beam. So I can add in a description. So let's add a floor load, for example, and then let's add in some loads. So let's do 0.5 kilonewtons per meter and 0.6 kilonewtons per meter for the dead and the live load respectively. And it will actually plot these loads on the diagrams below. So if I scroll down to the bottom here, you'll see that it's actually plotted that UDL load there. Okay. If I go back up, we can add some point loads in here. So let's do a point load. Just call it point load 1. Let's give that a value. So 1 kilonewton and 2 kilonewtons for the dead and alive. And we need to put in a position of the load from the left-hand edge of the beam. So we've got a 3 meter beam. Let's put it in the middle. 1.5 meters, and if we go down, we can see that plotted. So that's the point load being plotted on the beam. And then also let's add a partial UDL load. So partial load 1, and then we can add in that. So let's put in 0.2 kilonewtons per meter and 0.3 kilonewtons per meter for the dead and alive load. We need to also put in the dead and alive load at the other end. So let's do 0.4 and 0.6. And the distance to the load, let's do 1 meter, and the length of the load, let's do another meter. And so if we scroll down, we can see that trapezoidal load has been added. So you can see the load starts off at 0.2 and goes up to 0.4 for your dead, and it starts at 0.3 for the live and goes up to 0.6 for the live load, and it starts at 1 meter from the support. So this distance from here to here is 1 meter, and the length of the load is 1 meter as well. Okay. So that's how you add a partial load. And then if we scroll down further, we can have a look at all the results for this. So we've got our internal forces, so we've got our maximum bending moment and shear forces at ultimate limit state, and also the distances to those maximum moments and shear forces. We've got the reaction forces at the left and right hand support. So we've got both we've got those at SLS and at ULS as well. So SLS is serviceability limit state, which means we're not factoring the loads up at all. We're just putting, the loads as they are inputted up here. But we've also got that expressed at ULS as well. So we've got the permanent load reaction, the variable load reaction, the total load reaction unfactored, and the total reaction force factored at ultimate limit state at the left and right support. We've also got the reaction moments at the support, and as you can see, these are all 0 because it's a pin-pin situation, so that we're allowing the beam to rotate at the supports. So a moment cannot be generated at the support location, so these are all 0. We've also got the deflections, and these are all the deflections that are at serviceability limit state, so unfactored loads. So we've got the deflection from the dead permanent load up here. We've got the deflection from the variable load, and the deflection from the total load. And we've also got the deflections expressed as a ratio of the span as well down here. So that's all of our our sort of outputs and our information, and we've also got the plots as well, which show the bending moment, the shear force, and the deflections as well. So that's what the design sheet is doing. But what we can also do in here is we can also save out all of this design data to our saved design sheets in here. And the way we do that is we go back to our design sheet, we go over to here to the project controls, and in the design number, if we want to append a design to the table, we put a value of 0 in here, and we hit save design to database. And if we go to the save design database, you can see it's outputted all of the input data into this table. Okay, we can also keep appending to this table. So if I keep on clicking save design to database, when we have a 0 value in here, it will just continue appending. See, it's continue to append. But we can also overwrite values in this table as well. So if I input a value of 1, it's going to overwrite the first design that we saved out. So if I click save, it's going to ask me if there may be a design that already exists. I can go yes, and what it will have done there, it will have overwritten this first row in the database. Okay, so that's what that's doing there. So we can save out all that information. We can also reset this design sheet, reset the project header, so it's reset all of the data back to what it was when we first opened the spreadsheet. We can also PDF the current design. So if we go PDF, it will allow us a place on our network drive to PDF that. I'm not going to do that at the moment, but that's what it will do. We can go to our diagram of loading as well over here. So we can have a look at, this is a diagram which shows how the loading is applied, which is obviously useful when we're looking at this table here. It sort of allows you to see how these loads are actually applied to the beam. So UDLs, point loads, and the trapezoidal load. And then finally, we can go down to here and we can set the print scaling for the design sheet. So obviously, depending on how you're looking, how your Excel sheet is working, how your print settings are, you may want to change this before you go up here and PDF your current design. So that's what that's allowing you to do. Okay. And then finally, we can go to our saved design sheets. We can look at all of our designs. We can load back in a design. So if we go up here and go to select design, we can pick one of the designs from the table. So let's pick design 1, and we can load that back into our design sheet. So that's loaded that all back in again. So we can do that. And we can also go back to the save design sheets. We can also move designs up and down this table. So for example, if I had a bunch of different designs, beam design, let's call this beam design 1, beam design 2, and beam design 3. If I pick the first one from the table, I can move it down like that. I can move it up like that. I can move it to the end. I can move it to the start. So that lets you rearrange the data in the table. I can also create a summary table. So if I click that, it's going to run through all the designs and output a bunch of summary data into this summary sheet. So this is run through every design that we've got saved, and it gives you all the information here. And you can print this sheet as well if you click on print sheet, or we can clear the table. And also when we're printing the sheet, we can set the print scaling over here if you so wish. And also on the save design sheets, we can export all of the designs to PDF. So if I click on this, it's going to run through every design and it's going to export them to PDF. And it also allows you to set where you want those to be exported to. So we can do that. Well, I'm not going to do it now, but that's what that will do. We can delete a current design from the sheet. So if I pick design 3 and delete that, we'll delete it from the table. And we can delete all the designs from the spreadsheet like that. And also, if we've started to go in here and mess around with our colouring, so let's, for example, say we wanted to add some weird colouring as well, because we were doing a bunch of beam designs, we wanted to help ourselves by changing the colouring of these rows, we can reset the row colouring as well. So I'll run through that. It's going to reset the row colouring back to how it was before. So that's basically how to use this design sheet and try and get the most out of it. There's quite a lot of tools that are helpful here, like the adding the summary table and everything. And hopefully this will help you with your design work. I hope this helps, and I'll see you in the next one. Okay, bye bye.